So we've got Professor Shroof to come up now for our final 15-minute session, and this is on his presentation on a fascinating thing called, an imaginative thing called ENRoads.
All right. Thank you for having me and to be part of this conference. Thank you for the introduction, Jerry. And I'm doing more than a presentation. I'm hopefully doing an interactive game with you. I want to do some scenario planning, and what this will take us out into is 2100, based on what we can do and how we can make policy changes on a global level. So within this context, I'm actually presenting, if you will, or walking us through something that's called Climate Interactive. It's actually created by MIT Sloan, the business school. Myself, I'm the Murrin Chair of Global Competitiveness at Duquesne University's MBA in Sustainable Business Practices program. We're the #1 ranked program in the United States for the integration of sustainability into a 12-month MBA program that includes study abroad and live project consulting work with area companies like Involvement and others, almost 200 of them to date. But while doing this, we also do it in the context of how we can take action to make change to influence the future. So part of this is what's been created by MIT Sloan. And what I want to do today is set a target for us. Our keynote speaker last night talked about having climate change goals of keeping us within 2 degrees Celsius for the future. That is our current goal from COP26, which is the Conference of the Parties from last year in November. COP19 in 2015 was the largest gathering of countries that came together to do this and actually agree on something and try to hold each other accountable to some extent. And when doing it at that time, the goal was 1.5 degrees Celsius. So what's behind me is a little bit of a backstory as I try to walk you through this, but it's a systems dynamics model. And it's to help us think about policies and actions that will influence our global future. It's the integration of it's the integrity of creation in which we're doing this today, because it's exactly that we get to influence through what we do and what we can do. This is also part of climate resiliency in terms of what we're talking about within this conference context. So MIT has put together this, and it's actually built on the best available science. There are 35,000 linear equations behind this. It's a live interactive model that we can run in less than 1 second. This one has had 13 years of development behind it before its last release in, I think, July of 2021. But it takes on the best available data that we have available to us, and that is from the IEA, the International Energy Agency, the IPCC, the Intergovernmental Panel on Climate Change. It's open source. They provide you all the equations. You can get to a 400-page document that is just the reference document, and these things are all embedded inside the model itself. And I'll show you how some of that works a little bit later on. It's also been tested, so every month they test it when new data comes out, new empirical evidence is science-based, comes out and it might change or influence the model. They take this into account to provide that information to all of us at no cost. So we can always go to this website and interact with it and try to think about how we can influence the future. It's at a global stage when doing this, but it's also transparent in terms of they want you to be able to see where this comes from. There's nothing to hide, but it is deeply complex. So they try to make it as easy as possible with the interface that we have in front of us. So in that context, on the upper left-hand side of this is our global sources of primary energy. Our right-hand side, greenhouse gas emissions. It's already taken into account the past 22 years behind us, so it starts at 2000 and takes us out to 2100. Based on known available data sources, and those data sources are actually hidden within 100 plus other graphs that are behind this, but we can go into different views to get to them. And what this is primarily based on is global population times GDP per capita times the energy intensity times the intensity of final energy to then get us to CO2 emissions from that energy source to come up with those final graphs. So this sets the stage for the visual representation of what takes place in large data sets and computers churning away at this usually over hours, but they provide it to us in less than a second online. To the right, we see our targets, right, in terms of where we want to end up in the future. Do we really want to do business as usual or do nothing right now, which is what we're on course to do? It gets us to 3.6C. May not mean much in the American context, right? We need to flip it into Fahrenheit. And those conversions are always tough for us. But instead, we're really looking at something over 6 degrees. And some have told us there's nothing we can do about this. We're on this trajectory and it can't be changed. Others, and you may have heard this in other different ways through the research that was presented at panels and through other times throughout the last decade or more in your life, that there are other opportunities for us to take advantage of. So instead of passing around a microphone and getting people to raise hands, if you want to try to interact with me in this process, tell me maybe what you've heard, and I can take you through what these sliders do, because we have energy supplies that we can change. We can either provide subsidies for these and subsidize them more. We can put a price on them, or what's also called a tax. I presented something with a team of my students to Congress in January 2020 of the impacts of putting a carbon price on something like the state of Pennsylvania, and how much it would include in terms of jobs, revenue creation, and the positive benefits this would have for our society. So these things are kind of baked into this, but it's at a global level that we're talking about with this model. We can change things for energy inputs to it, for transportation, for land and industry emissions. These are all the opportunities for us to interact with our future by right now running this model. So in that context, when you get to the model yourself, and you can always go to this online, you can click on the 3 buttons. That's just the information source. It tells you what's behind this. If you scroll through it in different aspects, it can tell you how many options you can change or what you can move around and do with this. Click on the information button again. It gives you the examples of this, case studies behind it, the actual cited references for this information, where it came from, how they include it in the data sets, and this is part of their transparency. But after 13 years of development, this is the point they could get it to make it easy for us to interact with. So what have you heard that will help us with climate change? What are going to be the big solutions that have been put forth that will help us bring temperature down over time? And this is an open opportunity for anybody just to shout this out. All right, so green buildings. We have some on campus, right? We have LEED certified buildings, so we know the built environment is an opportunity for us, not only in terms of electrification within those buildings and those systems, but also the buildings themselves and making them more energy efficient. Now we can go in a different direction for this too, right? So we can go status quo or less than that. If we're gonna go and increase our buildings in terms of what we do with energy efficiency within them, how much do you wanna go? Do you wanna go a little, a middle amount, or a large amount? A little? Okay. Do you think a little is going to have a meaningful impact on the 3.6 degrees Celsius in terms of is it going to move it maybe a couple of tenths of a difference, a big difference, maybe 1 degree? What do you think? Okay. We're talking about small improvements, so we'll just move this a little bit. And if we look at that in terms of what it does, maybe a tenth of a degree difference. Right? So buildings are part of the solution, but they cannot be the only solution or one thing that we invest everything in. We can also go really high with this and see it does have a meaningful impact. So buildings are one thing, and they do help us. I'll just return back to space level. What else have we heard outside of buildings? What else can we do? What else is already happening and trends that are taking us in this direction of bringing temperature down? Yeah. Okay, electric vehicles, fantastic. So we can look at CAFE standards for the energy efficiency, right? Making the miles per gallon better with them. We can also look at electrification. Do we want to go a small, medium, or large amount with that? Okay, so medium amount. Again, if we look at that change, it's only about a tenth of a degree centigrade. And it's also going to take time for this to happen, right? We can hardly see the lines move. We can make this a little bit bigger in terms of we can blow up this, but if you look at where we are now versus where we start seeing some real deviation from this, it's going to take some time. So that infrastructure takes time to turn over. Combustion engine vehicles, we know, waste 81% of every gallon of gas you put in them. It goes towards heat and friction. The rest goes towards actual movement. E-vehicles are 90% more efficient in movement. So we've got buildings, we've got vehicles, so we can change transportation. What else can we do? What else do you think would have a big impact? Please. All right, so we can subsidize renewables, right? So you want to go little, medium, or a lot? All right, medium. It's not going to give me exactly where I want to try to put the pointer, but you get the gist of it. So even with a medium amount of this, we're providing subsidies to them. Some have adamantly been against providing subsidies to renewables, right? But if you think of those other industries that are represented here, coal, oil, natural gas, they've been subsidized for the last 100 years. To the tune of $11 million a minute. So if we've subsidized them for the last 100 years, what would we want to subsidize in a different way for the next 100 years that can make a bigger difference? Renewables would be part of that solution set. So renewables are, again, something else that moves us. What else do you think would have a big impact? What else should I move in terms of this? Nuclear, all right? So nuclear, little, medium lot? All right, everybody's kind of risk averse with the mediums or the smalls. But here we see not much of a noticeable change in Fahrenheit, yes, degrees Celsius, not as much so. But nuclear can be out there too because of zero carbon emissions from it, right? But a different risk and value proposition behind that in terms of the risk that might be associated with some of this. But these are, again, all opportunities that have, I think, been sold to us in the past as the silver bullets for this. What we find is that there is no silver bullet. Instead, it's silver buckshot. We can't plant a garden, right, with one seed. We need seeds. So we need more than one thing to focus on. Something that I heard on the radio just this morning is that Pennsylvania's legislature has put forth an opportunity to invest in carbon capture for the future, and that's how they would want us to focus and how this can be done, and carbon capture would be our solution. Again, it's one thing, right, to focus on, but carbon capture isn't proven. It's actually part of our technological solutions here in the future, and it's actually a bet that we'll get to it in the future, or that after enough time, economies of scale will bring it down, and then the cost structure becomes better for us. So this is part of what's been proposed as of today for Pennsylvania, but I think it's taking our eye off the ball. What this is really getting at when we're looking at CO2 emissions, where are the most intense emissions coming from? They come from coal, oil, and natural gas in that order. That's why you can see that represented in the graphs here in terms of the amount that you see in that wedge for them. Now, we've also been sold, I think, an idea that you've ever heard of planting 1 million trees as being part of the solution to this. Will bring down carbon emissions because of the 1 million tree movement. So people propose that too. That's part of afforestation, and it can help us. But for 1 million trees, and we can go into this and change some of the model assumptions, for afforestation, if I get to this, MIT noticed that we didn't really have enough land for this right now in terms of what we needed. So we need about 840 million hectare to do it. And that means we'd bump it up all the way. So if we go with afforestation, what do you think? How many tenths of a degree are we going to bring this down Celsius? All right, we had some presentations on this earlier, right? Some people are kind of getting at carbon capture in this, but let's go all the way. Not much, but a little bit more than some of the others, right? But guess what we had to do with 840 million hectare for this? If we also start looking at that in terms of land use for this, and then land for growing CO2 and removable biomass, that gray dotted line actually represents the area of India. So it also brings up equity issues, which I know was brought up by others in the research before. Where are we going to put this? We're not going to take a large chunk of land and put it over top of everything else, take away farmland, take away urban environments and all that is needed. So how are we going to disperse this? Who all is going to be involved? These are the kinds of questions we need to answer, but it is possible because it moves us in the right direction. And as we start putting these things together, not just one opportunity at a time, we can do something like change what we do with coal. Would we want to continue subsidizing it, or would we want to, do something else? We can put a price on it in terms of this. I see no in the back. We want to go small, medium, and large with our impacts on not subsidizing coal. All right, we got some large people. So I'm going to swing it way over here. We can get into the depths of this, but you can already see the change in that, right? In terms of just that coal wedge in the bottom part of this graph and how much that CO2 goes away because it's the most carbon intensive. And look, we have a much bigger impact. It's now cumulative because it's on top of afforestation. How about oil? Tax or subsidize? We can go middle of the road. Natural gas, we've been told it's the bridge fuel to the future. Maybe we can cross the bridge. Maybe we've already crossed the bridge and we didn't know it, but instead of subsidizing it, we can go maybe in the middle of the road somewhere with it also. Now look at this, we've gone down more than half of a degree Celsius. These things are the most carbon intensive for us. What else would you like me to try to move in terms of sliders? Economic growth? Okay, usually you hold off on that one until the end, but yeah, we can move that up a little bit because everybody wants growth, right? Or if we think about the stock markets, we want this stuff to happen in a growing way. Usually if I come back to that in the end, I can move it to both ends of the spectrum, and we'll find it doesn't have much of an impact after we have these other things in place. The other thing I do with my own students in our MBA program is we put a price on carbon dioxide. So for those emissions to have a value, then all of a sudden we're going to probably start reducing them because that value can be significant. It ranges anywhere from a couple of dollars to over 800. But I think we can bump this up a little bit. We can invest in new carbon capture or new carbon forms of energy that have low carbon in the future. But again, it's a guess. It's an investment in something that hasn't taken place yet and is way too costly in its current form. But we can throw some of that in the mix. We can increase energy efficiency of our combustion engine vehicles. It'll take 15 years to turn them over if you want to try to get to more electric vehicles. Same thing with our buildings. And we even have monitors within our business school. We can actually look at energy consumption in live, real time, refreshed every 10 seconds, and 5 measures of indoor air quality. Because we know that when we invest in buildings and bring down their energy consumption, it reduces CO2 emissions. It also makes for healthier spaces for you to perform better on tests in, to recover better in hospitals. But we can electrify this. We can look at deforestation and not cutting down as much as an acre per minute in the Amazon. We can actually look at reducing methane capture, because right now the natural gas industry report their own methane leaks. They report about 1% every year, and hopefully nobody checks. When it's more than that, methane's a 24 times multiplier of CO2 impact. So this should be something that we'd be wanting to watch. We can look at technological improvements and trying to capture something in the future and placing a bet on that. And then we can start looking at what's the impact of economic growth if it's really big? Not much, right? We can really increase this. And we haven't increased or taken away from GDP overall. We can also look at population impacts on this. It's per person, right, when we calculate it, so it will have some impact. But right now, we're just having a steady state with it. But congratulations, we were able to build a scenario that at least got us to COP26 last November. In the Conference of the Parties trying to target us to stay under 2 degrees Celsius. So what this means is that this is based on existing technology. We can do this. We don't have the time to go into everything that's behind it in terms of all the depth of the economics behind it, the equity, the environmental justice, and social justice opportunities, but they're all interconnected. So if you take 60 seconds to think about what it would be like to be part of creating this future and to be in that future in 2100, I'll start a timer right now. And at the end of that 60 seconds, if there are any words that come to you that make you feel something about what this would be like, just say them out loud. That would be 1 minute. How did it make you feel when this has happened before, and I do with my own students? The kinds of things that usually come out of this is hope, inspiration. We're eager, we're ready for action. It's powerful. This is part of the conference in terms of our sub-tagline for collaboration, adaptation, and action. This is doable. You are the ones that are going to be able to do this. I'm not going to be here in 2100. Some of you may be. Your children, yes, they probably will be. It's what we do between now and 2030 that makes the biggest difference on what that world will look like. So thank you for allowing me to take you through this scenario.
Thank you, Dr. Schroef. A very imaginative, captivating end to our presentations. So we have just over 10 minutes, just under 10 minutes now, about 7 minutes to go. We've got the final plenary presentation coming up at the half hour. So take a break. If you want to stay, class, you're very welcome to stay. If you want to spend a few minutes going to the tables on the way through, please do so. Thank you all for participating in our session today.